So we've seen aliquoting and dispensing and dilution. I like that. Now, one of the aspects of our daily work we've been considering in the lab is how can we improve the efficiency of pipetting and quickly, accurately, precisely adding a reagent or more than one reagent simultaneously, because we have a 2-syringe machine here. What solutions has the Microlab got to make our daily work more efficient?
Okay, I think really from the start, Chris, what we're trying to make people realise is the Microlab 600 is more than just a dispenser diluter. It's a complete liquid handling system. We're able to put custom programs and manipulate the programs to do almost any task. If we consider what you're doing at the moment with your pipetting functions, often we're pipetting small amounts of reagent along with small amounts of sample. So this is a duplication of effort in that we can use the syringe system to aspirate or fill from our reagent reservoir and add that along with our sample. So we can make the process more efficient by reducing the number of steps that you're going through. Because of the positive displacement system, we're getting two things. We're getting no differences between individual technicians because it's a more accurate process, and because we're adding reagent along with, that's following the sample, we're ensured of getting 100% recovery. So let's perhaps look at that. Simple way of doing that is consider it in maybe the wizards in a dilution format. Why dilution? Well, quite frankly, let's think of it as this one. We're just adding 2 reagents. So we can go into dilution and we can set up the system. Let's try to initialize. There we go. Within this step, we've got a simple stage of adding diluent volume and sample volume. We consider we want to input a diluent volume, in other words, the first reagent, and say you're putting, I understand, is it something like 250 microliters as your reagent? So we're going to actually put...
It's a range of volumes, but show us that to start with.
So I can enter the 250 microliters, and then it's going to ask for the sample volume, and realistically, how much would that be?
250.
Similar amount, 250 microliters. So
50 to 250.
Okay, let's go midstream. Let's do 100 microliters for you, just to give an idea. So we're going to pick up 100 microliters of sample.
The important thing for us is we can quickly change both volumes. So for this demonstration, the actual volume's not that critical.
Yeah, that's fine. I mean, in this format, because the wizard allows us to select these very quickly, it's there. Or we can save these as a custom program if you have a method you're repeating a lot. So we can look at that later maybe. And I've also got in this an option to put an air gap actually between the sample additions, which I'm going to do. So I'm going to add a small 10 microliter air gap between those samples. And we're going to have at the end of this a wash volume, which I'll explain when that step arises. So we're going to have a wash step. And we've entered that.
Is there a guide to the wash volume? Is it twice the diluent volume? Or
I usually
depends on the viscosity of the liquid. How does
you've got it? You're addressing all those parameters. We would validate the methods anyway, but as part of that, I would normally expect to have greater than 5 times the volume of diluent to sample. Normally around 10 times. So it wouldn't be unusual to, once we've purged through here of the 100 microliters, we're actually adding 250 microliters of a general reagent which is used, but we may increase that to add a larger volume. So I've put 5 mils here, but let's put a smaller volume. Let's put 2.5 mils of material in here of reagent. So that's actually given us a 25 times plus dilution, which gives us a confidence that the material is totally cleaned and not getting carried.
So no cross contamination.
Exactly. So once that's done, as with the other programs, we can initialize a program either with the run button here or the actuation key on the front of the unit, and the indicator says it's ready to operate. So the first stage is it's actually taken up our 250 microliters of reagent automatically, and now this highlight actually around this blue indication that it's ready for its next step is to pick up our next reagent, next sample. So I have our sample which I'm going to dilute. We've already picked up the small air gap.
Yeah.
I'm going to aspirate that amount of material and then aspirate a small air gap that follows. And now I'm able to...
Now we're ready to dispense. So
Wipe
wipe
the
the probe. Now we're ready to dispense. The arrows are pointing upwards.
Exactly, and then in that
Yeah.
step what it's actually doing is it's dispensing out of the system my 100 microlitres and my 250 microlitres at the
Yeah.
same stage. So I've only aspirated one, it's actually carried out the further step automatically, and you can see what it's also done is aspirated 2,500 microlitres or 2.5 mils of the reagent to follow, and that allows me to do a wash step, which I can, by depressing, just wash through that material to ensure that we've cleared.
Yeah.
And that's then ready for the next stage. It's already aspirated the reagent again, taken up our air gap,
Yep.
and we can continue with our sampling process in the same way.
Yeah, good. And we can choose to wipe the probe or not,
Exactly.
depending on the
With
process.
volume's concerned and air gap, I can wipe it if I chose to.
Yep.
And then that allows me to dispense in the same way. So here we've reduced the number of steps in the process to just 2, because obviously we're using the reagent reservoir to fill and dispense that. But there are opportunities to increase the number.
Yeah. So we could add another reagent after that. So we filled our tray, our rack of vials. We could then subsequently add another reagent
Exactly.
as part of the same procedure.
We have great flexibility in the system, so we've actually looked in previous presentations the custom programs, and I've just saved this same program
Yep.
here by using the save command,
Yep.
and then saving these functions, but then adding some other text to the operator to let them know at what stage they're at.
So those are the prompts we saw on the dilution.
Exactly. So I can use that and go back into the functions here, back into the main menu. If I look into custom methods now, we can look at your assay you're carrying out, which is the TriCAD method. Once we've initialised that, we can take that into run mode again. And this is essentially the same program, but we've added an additional step where we're picking up an additional reagent, and I'll show you how that operates. So by initiating from front command here, from run, we direct the probe to waste where it zeroes the display. And the first thing it's saying
And there's
here,
my prompts.
it's filling with the diluent, which actually is picking up the diluent actually into the probe itself. And the next step is here, it's telling the operator to aspirate 250 microlitres of reagent E. So reagent E is picked up, automatically an air gap has been aspirated, and they can pick up 250 microlitres of reagent E. You can now pick up another small air gap, wipe the tip, and now we have our sample. It's pick up 100 microlitres of your TriCAD sample.
Yeah, excellent.
We've picked that up. We can take an air gap, wipe the tip, and then on our last dispense, we're actually taking over both the sample, reagent from the reservoirs or into the one container, and it's taken us directly onto the next step, which was its dilution step. It's a wash step.
Yeah.
So the benefits of this are the fact that we're not using sample tips. We're assured of 100% recovery of sample. We're taking the users through a standard workflow so they know what stage they are. And because we can validate this system with full traceability, we have a greater level of confidence the analytical data we're getting from this is both accurate as well as being precise.
So we really do cut down the between analyst variability.
Exactly, and it's cutting down those consumables, and the efficiency, the workflows can be greatly increased. You would imagine the operator having 3 pipetting steps using maybe 1 to 2 different pipetters, taking them off, the repetitive strain issues that come in, but here we've got everything actually into one program.
Yeah, and we like the idea of in real time, the workflow being displayed on the screen so you know exactly what you've got to do, where the probe has to be and what's going on if you're distracted. So
exactly.
very good, thank you.
Good.
Yeah.